Good afternoon, student. Myself Satyaveer Singh, Assistant Professor at Department of Civil Engineering, IIMT College of Engineering. Today, I have to give presentation on hydraulic turbine. This turbine is very beneficial for the civil engineering student point of view and also the mechanical student point of view. So, we will discuss in detail what are the different types of turbine and what is hydraulic turbine. Basically, turbines are defined as hydraulic machines which convert hydraulic energy into the mechanical energy. And we can say that this mechanical energy is used in running an electric generator which is directly coupled to the shaft or the of the turbine. So you can you can convert hydraulic energy into the mechanical energy with the help of the turbine blades, and after that mechanical energy is converted into the electric energy with the help of dynamo that is coupled to the turbine shaft. And so thus we can say that the mechanical energy is finally converted into the electrical energy. Now, if we talk about the classification of hydraulic turbine, then the turbine is classified on the following basis. The first one, we can say that according to the type of energy at the inlet. So, number one is the impulse turbine, second one is the reaction turbine. And if we talk about the classification of turbine on the basis of direction of flow of water, it may be of four types. First one is a tangential flow turbine, second one is axial flow turbine, and third one is radial flow turbine, and fourth one is mixed flow turbine. Basically, radial flow turbines are of two types: inward flow radial reaction turbine or outward flow radial reaction turbine. So we will discuss in detail one by one. And after that, if we talk about the classification of turbine on the basis of the water head and quantity of water available, then this is of three types. First one is high head and a small quantity of water to flow, and second one is medium head and medium flow rate turbine, and the third one is low head and large flow rate turbine. If we talk about the other classification of the hydraulic turbine, then it is based on the specific speed of the turbine. Basically, specific speed is nothing but only the speed of geometrically similar turbine that will deliver the required power under a constant head. So we can say that if we talk about the classification based on the specific speed of the turbine, then first one is low specific speed turbine, in which there is specific speed is less than 60. Example of low speed specific speed turbine is Pelton wheel turbine. And second one is medium specific speed turbine. In this case, the specific speed vary from 60 to 400. And example of the medium specific turbine is Francis turbine. And third classification is high specific speed turbine. In this case, the specific speed is more than 400. Okay. Next, we talk about the detailed overview of the impulse turbine. In case of impulse turbine, this turbine is based on the impulsive principle. In what is impulse? Whenever we apply a force on the body for a short time, then impulse is said to be done. So, in case of impulse turbine, if at the inlet of the turbine, the energy available is only the kinetic energy, the turbine is known as impulse turbine. So, in case of impulse turbine, only kinetic energy is available at the inlet. For example, Pelton wheel turbine. But in case of reaction turbine, the water energy as well as you can say that if at the inlet of the turbine, water produces kinetic energy as well as the pressure energy. It means if both type of energy like kinetic energy and pressure energy are available at the inlet of the turbine, then turbine is called as reaction turbine. Okay. Example of reaction turbine is Francis turbine and Kaplan turbine. Now, next classification is radial flow turbine. If the water flow in the radial direction through the runner, then turbine is called the radial flow turbine. So we can see that in case of radial flow turbine, the flow of water is in radial direction through the runner. Runner is basically act like a wheel, and it stores the energy. And inward radial flow turbines, radial flow turbines are two types: inward flow and outward flow. In case of inward flow radial reaction turbine, the water flows from outward to inward, and the turbine is known as inward flow turbine. But in case of outward flow radial reaction turbine, the water flows from inward to outward. Okay, the turbine is known as the outward flow radial reaction turbine. So these are number of types of turbines. Next, we can say that axial flow turbine. What is axial flow turbine? So you can say that in case of axial flow turbine, if the water flow through the runner along the direction parallel to the axis of rotation of the runner, then a turbine is called the axial flow turbine. And in case of mixed flow turbine, if the water flows through the runner in the radial direction but leaves in the direction parallel to the axis of rotation of the runner, then turbine is called the mixed flow turbine. Now, if we talk about the tangential flow turbine, then this classification indicates that if the water flows along the tangent of the runner, and the turbine is known as tangential flow turbine. We can see the example of this type of turbine. So if we talk of the design criteria of impulse turbine and reaction turbine, so first of all we can see the figure. So this is the first one is the impulse turbine. In case of impulse turbine, we can see the bucket here, and this is the runner. On runner, the buckets is also known as vanes or the blades. So on the runner, blades are fixed, and with the help of nozzle and spare rod arrangement, we can control the flow of water that is directed onto the bucket or the blade of the turbine. Basically, whenever we projected water onto the bucket, then bucket starts rotating, and due to the rotation of the bucket is fixed on the turbine runner, and runner is fixed on the shaft. So the turbine shaft is rotating, and the hydraulic energy converted into the mechanical energy. So first of all, we will talk about how the water comes in the turbine chamber. Basically, water from the penstock to the turbine via one or more nozzles. So we can use one nozzle or the more nozzle to project water on the bucket or the blades of the turbine. Basically, second one is the pressure energy converted into the kinetic energy, because water under pressure supplied into the turbine chamber, and this water is projected on the bucket. When water strike on the bucket, then an impulse is created on the turbine bucket, and due to this impulse, turbine that is runner starts rotating, and due to the rotation of the runner, the turbine shaft also rotated, because runner is fixed on the shaft. Next one is the rotation of the wheel due to the tangential force created by the impact of jet. Basically, there is an impact of jet here, and this is the bucket, and in case of buckets, in center there is a splitter ridge and section through the bucket. So we have sectioned the bucket and sectioning this part, and the figure indicates that the rotation of the wheel due to the tangential force acting on the bucket, due to the when the pressure energy, when the hydraulic energy of the water strike on the bucket. Now, in case of reaction turbine, first of all, we can see the figure of the reaction turbine. In case of reaction turbine, both kinetic energy as well as the pressure energy available at the inlet of the turbine. And second one is the feeding of the water through the fixed blade in casing. So we can say that in case of reaction turbine, we can feed water through the fixed blade. There are two types of blades, that is a fixed blade and other one is moving blade. Okay. So, and third one is static pressure at inlet is greater than the outlet of the runner. So, and fourth one is rotation due to impulse reaction and due to the reduction in the pressure. So, it is called the reaction turbine. Reaction turbine is also called the pressure turbine. And we can see the figure of the reaction turbine. In this case, there are two types of blades. One is a fixed blade and another is that is movable blade. Okay? So we can say that this is the guide vanes, and these are the runner, and runner is rotating with the shaft, and the shaft is rotating with any RPM. RPM indicates for revolution per minute, and there is a volute casing. This is the volute casing of the reaction turbine, and water from the penstock pipe comes into the turbine chamber. Penstock is a large diameter pipe that supplied liquid from the dam to the turbine chamber. Basically, we can see the bottom view of this turbine. Here we can say that the water comes from the volute casing, and it after working on the turbine blades, this water goes down through the tail race, and a draft tube is provided with the reaction turbine, and this draft tube is basically a increasing diameter tube, and it can control the velocity of the flow. Now, what are the main difference between the impulse and reaction turbine? So we should all know. First one, in case of impulse turbine, all the potential energy is converted into the kinetic energy by nozzle before entering into the turbine runner. It means in case of impulse turbine, potential energy is converted into the kinetic energy. But in case of reaction turbine, only a portion of the fluid energy transferred into the kinetic energy before the fluid enters the turbine. Okay, so in case of impulse turbine, potential energy converted into kinetic energy, but in case of reaction turbine, only a little portion of energy, that is fluid energy, is converted into the kinetic energy. In case of impulse turbine, we can say that the flow regulation is possible without loss. In impulse turbine, flow regulation is created by a nozzle and sphere rod arrangement, but in case of reaction turbine, flow regulation is possible with loss. Now, the impulse turbine unit is installed above the tail race, but in case of reaction turbine, the turbine unit is kept entirely submerged in water. Or you can say that in case of impulse turbine, the blades are only in action when they are in front of the nozzle. But in case of reaction turbine, blades are in action at all the times. This is basically the figure of Francis turbine. This is the actual view, that is, you can see into the plant or physical view. In this Francis turbine, basically this is a mixed flow turbine, and here the water supply chambers are there. So this is the water turbine, and this is the water discharge, and this is the tail race. So this is the systematic the systematic view of the Francis turbine, and this is also the Francis turbine in pictorial view. We can say that we can design and develop the reaction turbine by American engineer James Francis. So James Francis was the engineer who has designed and developed the reaction turbine in 1848. Head engineer in textile factory city of Lowell, Massachusetts, and improved of this design to create a turbine with 90% efficiency. It means that the reaction turbine is basically that is created by James Francis have efficiency more than 90% or equal to 90%. Now, what are the design criteria of the impulse turbine? So we should all know. The first one is the design. This turbine is designed by the American scientist, or the you can say that engineer. Names is Francis in 1848, and this turbine basically inward reaction flow turbine, or you can say that inward flow radial reaction turbine. Okay. Now, what is the water head? Water head is about 10 to 650 meter. Water head about 6 to that is 10 to 650 meter in case of a reaction turbine, and power output range is 10 megawatt to 750 megawatt we can generate with the help of the reaction turbine. And the speed range, if we talk about the speed, that is 83 to 1000 rpm we can take. In case of old Francis radial reaction turbine, these are based on the discharge at outlet, and in modern Francis turbine, water enters radially from outlet periphery and leaves the runner in the axial periphery. What are the main components of the turbine? There are 5 main components of the turbine, that is of reaction turbine. So the first part is spiral casing, guide vanes, and the next is the runner, governing mechanism, and draft tube. Basically, generally the spiral casing is made up of concrete or cast steel, but guide vanes basically are the vanes that can guide the flow of water that is entering into the casing. And runner is basically the rotating part, is act like a flywheel, and on the runner the vanes are fixed. Next one is governing mechanism. So there is a flow that is speed control mechanism that will control the flow of water. And the next one is the draft tube. Draft tube is the part of the that is reaction turbine, and it is the increasing diameter tube, and it can control the velocity. It can control the velocity of flow, and this is the most common type of turbine that is used in hydroelectric power stations. Basically, this is the main pictorial view of the Francis turbine that is basically used in the industry, and this is called the turbine shaft. We can see the picture, and this is the turbine shaft, and this is basically the governing ring, and this is guide vane, spiral casing, and you can say that this is the runner. Runner is the rotating part, and this part is known as the draft tube, and this is the lower chamber, lower cover, and this is the upper cover. So this is basically the main picture of the Francis turbine. This is a bigger Francis turbine that is installed in case of hydroelectric power plants. So there are number of parts that is installed, that is turbine shaft and guide vanes. Okay, so large number of parts are there in case of the Francis turbine. We can talk about the different parts, what is the working style, what is the working nature. And the first one is the penstock. Penstock is a large diameter pipe that is used to transfer water from dam to the turbine inlet. Penstock is made up of generally the steel. And the next one is the spiral casing. Next part is spiral casing. Spiral casing is basically a closed passage, or you can say that the closed chamber, whose diameter gradually decreases along the direction of flow. Area is maximum at inlet and nearly zero at exit. And to maintain the constant flow rate, we can use numerous opening in the casing. The purpose of casing to distribute water over guide vanes and prevent formation of eddies. And these casing can make the chamber airtight or watertight. Spiral casing is generally made up of the cast steel, and it also made up of the concrete. Next one is the guide vanes. What are the guide vanes? So guide vane is just it is the airfoil shaped vanes fixed between the two rings, and it can convert a part of pressure energy into the kinetic energy. And each guide vane can rotate about its pivot center, and hence it also serves to direct and the flow at design angle to be the blade runner. What are the governing mechanism? The governing mechanism is basically to control the flow of the turbine, and it is the next is the runner. What is runner? Runner basically just act like a flywheel, and runner rotates due to its impulse and reaction effect. It is generally classified to fast runner, medium runner, and slow runner, etc. And it is made up of cast iron, and for a small unit, it is made up of stainless steel for the large unit, and it made up of the bronze for the impure water if we used in the turbine. And this runner is basically key to the shaft of the turbine. Okay. Next is draft. What is the function of draft tube? So it is generally expanding tube which discharge water passing through the runner to the tail race, and generally with increasing diameter in direction of flow. So draft tube is basically increasing diameter tube, and it is of 4 types. Generally we use in the industry. If you talk about the classification, further classification, so we can say that low speed and high speed turbines. Based on the design, they can be low and high speed. This is the systematic view of the Pelton wheel turbine that is installed in the laboratory for the experimental purpose. So this is basically the shaft, and these are the buckets that is fixed on the runner. Runner is the rotating part, and this is the chamber in which water is filled. Next, we talk about the Pelton wheel turbine. So Pelton wheel is basically transfer. You can say that the Pelton wheel is a water tangential flow impulse turbine. Okay, here the impulse turbine, that is tangential flow are there. It was invented by Alan Pelton, that is an American scientist, and this turbine is used for the high head. So this is basically high head and low discharge turbine, and the main component of this turbine are the nozzle and spear rod, runner and bucket, casings, and braking jets. These are the main parts. Now we will discuss the main component of the Pelton wheel turbine that is shown in the picture. Basically, there is a turbine shaft, and this is the turbine runner, and these are the buckets. Buckets is also known as cups of buckets or the blades. This is the Pelton wheel, and this is the nozzle and spear rod arrangement. This nozzle and spear rod arrangement can control the flow of water that is striking on the that is bucket of the water, bucket of the turbine blade. You can say that the nozzle with the help of nozzle we can supply water, or we can strike water on the bucket. Okay. The shape of the bucket is double hemispherical cup. Nozzle and spear. What is the function of nozzle and spear? Basically, the amount of water striking the bucket of water controlled by the spear in the nozzle. And this is the figure, that is jet impinging on the bucket. So these are the jet, and that is impinging on the bucket. Bucket means that is the blade of the turbine. Spear is basically conical needle which operated either by hand, wheel, and over automatically. Actually depend on the size of the unit. Now, what is runner? Runner, it consists of a circular disc on periphery of which the number of bucket evenly spaced are fixed. Okay, the shape of bucket is of double hemispherical cup, and each bucket is divided by splitter line, which divides the jet into the two parts. So we can say that the jet is divided into two parts with the help of a splitter line. And we can say that the runner is made up of cast iron, cast steel, bronze, and also it made up of the stainless steel. What is the function of casing in case of Pelton wheel turbine? The casing can prevent the splashing of water and makes the chamber airtight or watertight, and it acts as a safeguard. And made up of the cast iron, fabricated steel. So these are the number of ways we can use. And braking jet. What is braking jet? That is a jet of water used to stop runner in a short time. So if we want to stop the turbine for a short time, then we can use the braking jet. Braking jet supply water in the direction opposite to the direction of runner, and we can stop the turbine in a quick time. So what is this is basically we can discuss here the types of turbine, and there are two main types of turbine: impulse turbine and reaction turbine. Okay. So we can overall completed the two types of turbine, that is the impulse turbine and reaction turbine. Thank you all, thanks all, and we'll discuss in the next lecture. Okay.